Okay, so on page 36, you see that the word problem says the number of DVD players sold in the U.S. from 1998 to 2003 can be modeled by f of x equals 1500x plus 500, where x is the number of years since 1998. Assume partial years and partial DVD players. Now, first of all, that makes no sense, right?
Yeah.
You don't, well, partial years makes total sense, but you don't buy 3/4 of a DVD player, right? So,
Some people.
from now on, since we've gone over what's discrete and what's continuous, we can talk about it. This really should be discrete. But we're just going to draw a continuous line because it's a lot easier. Okay? So from now on, we're going to make our lines continuous, but we will discuss whether they really should be discrete. So, the first thing here that I think is tricky is it says years since 1998. Now, that means you're not going to put 1998, 1999, 2000 on your x-axis. Anybody that writes 1998, 1999, and 2000 down there, it's wrong and you won't get credit. Okay? Because it's years since 1998. So if we're in the year 1998, how many years have passed? Zero. In 1999, it's 1 year. 2000 is 2. 2001 is 3. 2002 is 4. And 3 is 5 years. So I really recommend making a chart for these. That did not take long at all, and it makes it easier for us to see. So now, this is why I made the increments for years. 1, 2, 3, 4, 5. Years went on the x-axis because time is always the independent variable. DVD players went on the y-axis. Now, if I plug in 0, 1, 2, 3, 4, 5, I do f of 0 equals 1500 times 0 plus 500, and that equals 500. F of 1 is 1500 times 1 plus 500, which is 2000. F of 2 is 3000 plus 500, so 3500. F of 3 is going to be 4500 plus 500, which is 5000. And this is 6500, and this is 8000. So you find those values by plugging in your amounts. Now we're going to graph, okay? And I already did the increments for you, but before I wrote these increments, I did figure out what f of x would be, so I knew how to count. Obviously, I'm not going to count by ones. So 0 is 500. Let's just zoom in a little bit. Okay, 0 is 500, 1 is 2000, 2 is 3500. I'm off there a little bit. 3 is 5000. 4 is 6500. And 5 is 8000, so I went. There we go. Now, I said assume a continuous graph, so we're going to draw a ray. Now, it also wants us to find out what the domain and range is. Now, what that means is, and we'll just zoom in for a little bit here. When you find the domain and range, you ask yourself, what is the minimum possible x value, and what is the maximum possible x value? So who can tell me what the minimum x value is and what the maximum x value is?
The minimum is 0, the maximum is
Infinity, right? Because of the arrow. So our domain x is greater than or equal to 0, but it goes up to, oh, actually, I'm wrong. I am wrong. Why am I wrong? Exactly. I ignored the data. The data only went to 2003. We only have data for 5 years. So I was wrong. I was supposed to do a line segment, and I drew a ray. Now that we know it's a line segment, I know my domain is in between 0 and 5 because 5 is the maximum I can go. And when you have a line segment, you have 2 endpoints, right? So now I know the range is also going to be a compound inequality, right? So what's the minimum y value? 500. So 500 is my minimum y. And what's my maximum y? 8,000. So my range should be in between. Now, technically, because I used f of x, this should be f of x, but I will always accept y. Okay? Now, part B says, find the value of x so that f of x equals 6,500. There's 3 different ways you can do this on this particular graph. One way is I find 6,500 over here. I go from the y over here, and I go down, and I see the answer's 4. Okay? That's one way to do it. Use the graph. Another way to do it is I can use the table. I already did the math, and when f of x is 6,500, x is 4. The final way would just be take your equation, plug in 6,500, and say 6,500 equals 1,500x plus 500. I subtract 500 from both sides. I divide by 1,500, and we get x equals 4. Okay? So, that is that problem.